Hello friends, welcome to Minute Study. So in the previous video we have solved various signal manipulation operations which we can perform with our DT signal. So in this video let us consider one more example, one more DT signal, and let's perform certain signal manipulations on our DT signal. So consider our x of n here as 85241 to 852421, and consider 5 as our origin. So we represent a sequential representation and a graphical representation to solve in a convenient way. So let us 5 is my origin, so my origin is 5. On the left side I'm having 8, and on the right side 2421, so 2421. Now let us let's get started. The first question is basically we have to obtain x of n plus 2 for a given DT signal. X of n plus 2, we have to manipulate a given DT signal as x of n plus 2. So guys, in the previous video we have seen that if it is in the shifting, if it is x of n plus 2, plus means basically shifting it to the leftmost position, shifting it to the left side by given unit. So it is 2, so basically shifting the given DT signal to the left by 2 units. So let's shift this DT signal by 2 units. So it will be like 5 will be shifted, 5 magnitude, so 2 will be coming to origin, and one more, it will be shifting by one more unit since it is a 2. So 2 will be shifting ahead and 4 will be coming. So 4 will be my new origin. So my new x of n is equals to, it will be like 8 4 2 4 2 1, and 4 will be my origin. So this is a DT signal which you will be getting after performing a shifting operation on a given DT signal. So let's represent this signal in a graphical representation. Like 4 is my origin, so my origin will be 4. Okay, so here I'm having 2 5 8. Okay, and on the right side we are having 2 magnitude 2 and 1. Okay guys, you can also solve this problem using, like we using a long method, that is considering a new signal n is equals to y of n. So we consider y of n is equals to x of n plus 2. Then we consider that n is equals to 0, so y of 0 is equals to x of 2. Value of x of 2 is equals to 4. So just you can check, like for y of 0 origin is equals to 4, then y of 1 is equals to x of 1 plus 2 is 3, so x of 3 is 2. So x of 3 is 2. So y of 1 is equals to 2. Similarly, y of 2 is equals to x of 2 plus 2 is 4. X of 4 is equals to x of 4 is equals to 1. X of 4 is equals to 1. Then my y of 2 value is also 1. So you can also perform this operation, like this manipulation, by using a long method, or you can just guess, like if since it is plus, it will be shifting it to the leftmost position by 2 units. Okay guys, let's take other sum, like another sub problem, and that is we have to obtain x of n into u of minus n. Guys, you know, you must be knowing like u of n is basically a step signal we have seen in our previous video. So to solve this, this is basically a multiplication problem, like our x of n, our dt signal x of n is multiplied with the folded signal of our standard dt signal of step signal basically. So to solve this problem, we need to find a folded signal of a step signal. So we first consider, so let us first consider u of n. So how we represent u of n? We are having n and we'll be having a u of n. Okay, it is basically a step signal, so it will be 1 for origin, 1 1 1, and so on. So basically a step like form. Okay, so now let's find u of minus n, that is folded signal of u of n. Guys, we know in folded signal origin remains as it is, and we like we take right side on the left and left on the right side. So basically entire right side will be folded on the left side. So origin as it is, right side on the left side. So basically this will be 1, similarly 1, 1, 1, and so on. And here everything is 0, so here everything will become 0. So this is our new signal u of minus n, whereas u of minus n is basically a folded signal of our unit step signal. Okay, now what we have to find is basically x of n into u of minus n. This is basically a multiplication which we have to perform of two signals. So this is our u of n and this is our x of n. Guys, have a look, like u of n, the values exist only for origin and left side. Okay, and on its right everything is 0. So if we multiply this signal with this signal, origin value will be as it is, like 5 into 1 will be 5. So origin value will be 5. Okay, done. On its left we are having 8, so 1 into 8 will be 8, so minus 1 will be 8. Okay, similarly after 8 all the values are 0 for this given dt signal. So so 0 into 1 will be 0, so ahead values will be 0. Similarly for minus 3. Okay, now on the right side all the values are 0, and here we are having some magnitude values, but anything into 0 will be 0. So basically right side will become 0. So this is basically performing multiplication. You can also perform, like in a previous video which we have shown, like performing plotting a sequential representation and then performing a multiplication. You can also solve it in that manner. So this is basically a new signal which we get, like n, and this is x of n into u of minus n which we get. And let's represent this graphical representation in a sequential form. That is my x of n into u of minus n is equal, x of n into u of minus n is equals to, it is 8 and 5, where 5 is my origin. So this is what we get after performing x of n into u of minus n. Third sub problem is like we have to obtain x of n minus 1 into u of minus n minus 2. Guys, x of minus 1 is basically a shifting operation which we have performed on a given dt signal, and u of minus n minus 2 is a combination of shifting and folding, and multiplication of the both we have to perform. Okay, so let's get started. First let's obtain x of n minus 1. So let's obtain x of n minus 1. So this is our n, and this is our n minus 1 and n. Okay, yeah. So let us consider a new signal which we have to find as y of n is equals to x of n minus 1. Okay, now x of n minus 1, minus 1 means we have to basically, minus means we have to shift it to the right by how much unit? N minus 1. So basically on just by 1 unit. So for a dt signal we shift it by a 1 unit. So this 8 will become a origin, shifting right just by a 1 unit. So by origin will be 8. Okay, then on 1 we will be having a 5. 5. Okay, 8 will come here, 5 will move ahead, then we will be having a 2, then 4, then 2, and then 1. Okay, so this is what we get after performing x of n minus 1. Now we have found x of n minus 1. Now we have to find u of minus n minus 2. Okay, so u of minus n minus 2. Let us consider this new signal as y of n is equals to, and my y of n is equals to u of minus n minus 2. Okay, so y of 0 for n is equals to 0, it will be u of minus 0 minus 2, so it will be u of minus 2. And guys, we know a unit step signal, it exists one only for the origin. Just let me show you here. u of n, like for origin it is 1 and on the right side everything is 1 and on the left it is 0. So basically u of minus 2 is equals to 0. For n is equals to 1 it will be minus 1 minus 2, it will be minus 3, 0. Y of 2 is equals to u of minus 2 minus 2 minus 4, 0. Now let's find for some ahead also it will be 0. So let's find y of minus 1. Y of minus 1 will be u of minus 1 will be plus 1, 1 minus 2 is minus 1. So u of minus 1 is equals to also 0. Then y of minus 2 is equals to u of 2 minus 2 is equals to 0 and u of 0 is equals to 1. Y of minus 3 is equals to u of minus 3, it will be plus 3 minus 2, it will be 1, 1. So similarly ahead we will be getting 1. So let's plot these values, like for y of 0 it is 0, we are having a 0. For 0, then we are having for 1 it is 0, then for 2 also it is 0, minus 1 it is 0, for 2 it is 1, for minus 3 it is 1, and ahead it is also 1. So basically this is what we got, u of minus and minus 2. Now we have to perform a multiplication of these two. Guys, for this signal values only exist on the right side and on the origin, and for this signal right side and the origin is 0. So if we perform a multiplication of these two, everything will be 0. So the new signal which you will be getting is basically x of n minus 1 into u of minus n minus 2, and the values will be all values will be 0, like zeros multiplied by this values will be 0, and here everything is 0, and so here first value minus 1 is 0 and ahead is 1, but here everything is 0. So basically everything here also on the left hand side will be everything, all the samples will be 0. So this is what we get after performing x of n minus 1 into u of minus n minus 2. Okay, now let's take a fourth sub problem, like we have to obtain x of 2n minus 1, x of 2n minus 1. So let's solve this problem using a longer method which we are solving, like basically x of 2n minus 1. So let us consider a new signal, y of n is equals to x of 2n minus 1 for n samples. So y of n is equals to x of 2n minus 1. So for n is equals to 0, it will be like x of 2 into 0 minus 1, so x of minus 1, and the value of minus 1 is equals to 8. Then we'll be having y of 1 is equals to x of 2 minus 1 is 1, so x of 1 is 2. Then we are having y of 2 is equals to x of 2 2s are 4 minus 1 is 3, so value of x of 3 is equals to 2. Then we are having y of 3 is equals to x of 3 to the 6 minus 1 is 5, so x of 5 is equals to 0. Then y of 4, let's, for n is equals to 4, it will be x of 4 to the 8 minus 1 is 7, and for sample n is equals to 7 we are having a 0. So even if we solve ahead, like we will be getting a 0 value. So let's plot these values in a graphical representation. So for 0th sample we are having a magnitude as 8, suppose this is a 8 magnitude. Okay, for 1 we are having a 2, for second we are having 2, for third we are having like 0, similarly for fourth we are having 0. So this is what we get after performing x of 2n minus 1 on a given DTS signal. Okay, guys, take this as a homework, like if you want to solve on your own, like consider this DT signal x of n is equals to 2 3 4 5 1 3 4 is our origin, and now we have to obtain x of n minus 1. So this is basically a shifting operation, obtain x of n into u of minus n, like folding, we have to perform folding of first epsilon, perform a multiplication, obtain x of n minus 1, again shifting u of n, combination of shifting and folding, obtain x of minus n, folding into u of n, which is a step signal, and then we have to obtain x of 2n, which is a time scaling. So guys, this is a homework question. If you want to solve on your own, you can just take this DT signal and perform all these operations, and a solution to this homework question I have provided in a below link which is there in the description of this video. I hope you guys have understood the signal manipulations, and okay, thank you.